welcome to our math video presentation of lesson 7.3. We're happy you're joining us today. Today we're going to be working on the area of composite figures, and it builds on everything that you've done in the previous lessons. I wanted just to call your attention to our notes over here about the steps in solving this. You are going to identify shapes. Now notice it's become plural. Composite figures are when you have two or more shapes put together. And you are going to have to first identify each of the shapes that have been combined. Then you will select formulas. You will plug in values, solve equations. There will be a fifth step in solving for the area. And you remember, we're solving for that inside portion of each two-dimensional shape. You are going to, after you figure out all of the shapes, you will, and their areas, you will add all of those areas together to come up with a total area, or you will subtract to find the shaded area. Composite figures are, as it says, you can see it right here, they're made up of two or more shapes. And remember, they're two-dimensional flat shapes. So we can find the area of a composite figure by adding or subtracting the area of each shape, just to reiterate that. It's important for you to have your formula chart out so that you remember the formulas of each shape that you are looking at. As we look at the first one here, these are straight from your notes. We want to make the notes as easy as possible to understand. This composite figure is a combination of two shapes, and your notes have already shown you which two shapes those are. So as I look here, I'm going to just draw a line to separate those two shapes. I have a triangle, I now have a rectangle. I've done step one, I've identified the shapes. Step two, plug in the right formula. You're gonna write that down. So the triangular formula is area is equal to either base times height divided by 2, or on your formula chart, you'll see area is equal to 1/2 the base times the height. Then the rectangle over here, we plug in that, we write down that formula, which is area is equal to base times height. Now, I should have used plug in only for this one, but plug in is when we're going to substitute. We are going to take the numbers that we see here, and they're going to take the place of the variables that you see written. Let's look. Now, I know that the triangle is going to be the base times the height, and I look at my triangle and nothing is written. So this is where the shapes work together. A rectangle is made up of it has two sets of two parallel sides. So if this length here is 9 feet, I also know that this length will be 9 feet. But since it's joined together, I also now know the base of my triangle. I have been given the height of our overall composite figure, which is 12 feet. I've also been given the height of just the rectangle itself, which is 8, but nothing with the triangle. So I know if this is the total and this is a portion of it, to find the difference, I will subtract. So 12 minus 8 is 4. So I now know the height of my triangle will be 4 feet. And you see that number in the notes. Now that will make sense. The base is 9, the height is 4. You multiply that together, which is 36. You divide that by 2, and you end up with 18 feet squared just for the triangle. Over here, now you're into the rectangle. And we've already determined that the formula was area is equal to base times height. The base is 9, the height is 8. We multiply that together and get 72 feet squared. Then, to get the total area, remember we have a choice, we're adding or subtracting. But since we're finding a total and we're taking nothing away, we will add 72 feet, we will add the 18, we'll add them together, and we come up with 90 feet squared. I also want to say that setting your work up in a table like this is a super way to organize your work. That way you make sure that all the information you have for, like here, shape 1, the triangle, is all together. And all the information you have here for shape 2, the rectangle, is all together. You eliminate the opportunity to make a careless mistake. Over here we have another composite figure. This one is also combined with two shapes, and the two shapes are written below, a rectangle and a triangle. As I look at this, I can clearly see, and it's hard to draw the line because I can block it out. Here we go. Now it's easy. I have my rectangle and I have my triangle. I've done step one, I've identified the shapes. I am now doing step 2. I am selecting the right formulas. So the formula for a rectangle is base times height, whereas the formula for my triangle is base times height divided by 2. Now I plug in the number values. So for my rectangle, I see the base is 15 and I see that the height is 9. So I'm going to write 15 times 9. I then multiply them together and I know that the area of my rectangle is 135 meters squared. I've solved for the rectangle, but I still need to solve for shape 2, the triangle. Again, I don't see a base for my triangle. And that is where I know that with the parallel sides on a rectangle, this side is also going to be 15 meters. Knowing that, I can now find the base of my triangle. And I have, for that, I now have 15 meters, and then I have 5 meters for my height because the vertical line is your height. So I have 15 times 5, and I'm going to divide that total by 2. And so when you divide the 75 by 2, you end up getting 37.5 meters squared. And then, then we're not done because we are solving for the area of a composite figure. So it's asking for total area. You need to take these two areas, add them together, and that's where you come up with your answer, 172.5 meters squared. I'm going to scroll our notes up because we've done 2 examples now for total area. But, oops, I'm scrolling, but this isn't.
Go a little bit up on the mouse. Just go a little bit up.
A little up.
Okay,
on the
no,
mouse?
okay, no, there you go.
Okay. Thank you, Sorano. All right, let's get all, is that all up there on one shot? One page? As I look here, you're going to see the other part to solving for the area of composite figures. And this is where you start to see a shaded region. Once you start seeing shaded regions, then that is where you may have to first add a full total, but there will definitely be an element of subtraction in there because we're trying to find, we're looking at an overall shape, but then we're going to be taking a portion away from it. So over here it says a composite figure also includes overlapping shapes. Describe the process for finding the area of the shaded region. Well, this is how we would do it. We're going to find the area of this rectangle first, and then we're going to subtract the area of the parallelogram. And let's take a look at how that would be working out. So over here, as you look, here's an example with the numbers plugged in. Here is a combination. If you look at this one, you see a trapezoid, and then you see a rectangle. When you look at the trapezoid, the larger shape, we're going to first figure out that area. And as we look at that, here, remember, we identified our shape. Step 1, we've done that. Step 2, we're finding those formulas. Here's the formula for the trapezoid. Here's the formula for the rectangle. Now, we have to plug in those values. So let me raise this up so you can see. Step 2 was to select the formula. Step 3 was to plug in the values. Now, in that, we ended up having the bases of 15 and 10, and then we had a height of 8 for the trapezoid. If we look at the rectangle, we had a base of 7 and a height of 5. So this is really clearly showing you those 5 steps we go through. This is step 3 because we've plugged in the values. We're ready to solve now. We're going to solve this part in parentheses. So 15 plus 10 is 25. You bring down the 8. So we're over here now at 1/2. And then 25 times 8. 25 times 8 is 200. Divided by 2, and you get 100 inches squared. That is going to be the size of the trapezoid. That is the area of the trapezoid. But we need to also find the area of the rectangle. So step 2 was the formula, step 3 was plug in the values, and then we were solving the equation for step 4. So we know the rectangle is 35 inches squared, but we are solving for the shaded region. So therefore, we're taking the rectangle away. So we have to subtract the area in order to get to that. So we take our full size, the trapezoid was the larger figure, so we have the 100 inches squared. Then we subtract the area of the rectangle, 35 inches squared, to give us the shaded region area, which would be 65 inches squared. So just keep in mind as you have fun finding the area of composite figures that you do the same steps you've been doing all week, 1, 2, 3, and 4, but we have a 5th step today where we add all of those individual areas together, or perhaps you're having to subtract an area. And we hope this makes solving for the area of composite figures fun. We miss you all very much. We hope you're doing well. Thank you.